Waiting for this thing to start up. Don't know if this is working or not. See if I can find my channel. And looks like we're live now. Let's see. Hey, what's up? This is Dave, and I am doing some virtual co-working today. Gonna be doing some JavaScript stuff. I'm just monitoring myself here on the iPad. You can see my setup over here. So over here, I'll be able to monitor myself on this. I was using this as a separate display, but I realized I was sucking down USB bandwidth and killing my video, so I had to turn it off. I suppose I should plug it into one of the other devices. It seems to be working. That's good. So let me go back to this camera here. And what are we working on today? Let me type that into the chat. Today I'm working on graphing improvements. Graphing improvements to Meme, which is a project I'm working on. Not quite fully awake. Maybe I should have a little bit of coffee here. Seems like there's quite a bit of lag. Let's see if I can close this. Switch this to only the chat box. That will help cut down on some bandwidth issues, I think. Alright, so there. I think that's all set. I can see that. I can see me. I can see stuff happening here. Just shrinking everything down. Alright, so I'm also in the virtual co-working chat room. Looks like Courtney's here too, although I don't hear anything, but that doesn't mean anything. My volume is on. Assuming I'm coming through on the channel, not sure. Oh, thanks. Thanks, Courtney. Let's see. What am I working on today? So I'm just going to let people know in the chat room, starting a 1 hour co-working session. Let's see the audio channel. All right, so what was I working on? I'm working on graphing improvements to Meme. So what is that? Let me show you what I've been working on for the past week. This is running now. So what I'm running is code that will transform a graph, some graph data into a laid out graph, or a graphic. So graph data refers to, oh, that's interesting. That's a bug. Converts a data structure into a visual representation. They're both called graphs. So this is my my cheeseball code, which took me like a week or so to figure out how to write this. So this will take an arbitrary data structure, which is defined here. Here I'm setting. This is defining a bunch of nodes called just here for A, B, C, D, blah blah blah. It has some data with it, and then I'm setting the parents of a node, and then I'm setting the connections between nodes, and so. Here you can see that just the B node, which contains an A node, which contains a G node. Here's a D node, which contains C, E, F, and Y children. There's a rendering bug here. You can see it's drawing outside of its area. And then you know, these independent nodes. So I have a few commands that I wrote that will allow me to inspect, you know, the individual properties and call instructions on them. So I think comps will show me a list of what the, oops. Oh, it's called, what's it called now? Meme comps. Will show me the list of component levels, which are properties that are not children of someone else. So B, Z, D, and X. And so that's here. So once I have that, I can also do meme dump ID. If I wanted to see the data for A, I can, like, you'll see its various child information and so forth, and where it's drawing. So I just got this drawing code to work, so I can change these things arbitrarily. So if I wanted to, I guess, add some more edges. So let me add a edge here. That's the connect. You can only, so you can have multiple edges. So I should be able to connect from X also to A. And let's call it Xena. If I save that, I should add another edge, assuming everything is working. It's just running very slow because I am streaming in the background. So this might not be the best way to do it. So it's relayed out everything, so now I have the two A nodes. So what I want to work on today is, you can see it's drawing right here for the center, and through these opaque backgrounds, which is not what I want. It's what I really want to do is like draw from these edges. So I need to come up with an algorithm to draw those edges in places. So instead of actually writing code, I think I might just do some algorithm design stuff. That might be better. And oh look, here's a cat. The cat has come to say hello. Say hello, kitty. Yay. Hey, this ADHD life. Like, I'm glad you made it to one of these co-working streams. Let me formally greet you. Hey, ADHD life. Awesome. Okay, now we have a party. We have a quorum. So, anyway, this is, as I was saying, I'm going to try to, there's two pieces of code I want to write. One is to move these points to the ends of these things, which means I need to calculate, I think, the relative positions. Like if it's connecting, if the thing it's connecting to is on the right side, it should choose a point here. So the very simple version of this will be just to choose a top, I will say this, the top middles of each of these things somehow, and then determine that point. And I don't think the algorithm is that difficult, I just don't know what it is yet, so getting over that resistance. And then the other thing is I need to actually draw arrowheads on these lines here, and possibly also figure out like a better way to render like this text here. And then I think this will be ready as a handoff to the researchers to explore, to see if they can break it. Oh no. So Courtney says her cat is currently being shaved. Hilarious photos be provided at a later date. That's very exciting. I liked it when my cat was like all like line cut. He was adorable. Yes, you were. You were very adorable. Look how adorable you are. So it's kind of hard to work like this, but I guess we'll have to figure that out. Hopefully the sound is okay. And we're using this this external mic over here because I need to figure out a solution to how to wear glasses and have the head-worn mic without it being too terrible. But anyway, it is 11:45. I have about an hour to my first conference call of the day, and then I need to head out to pick up my glasses an hour away from here. So I guess we might as well get to it. Let me open up my timesheet. How do I do that? I'll go freelance. It's an Alfred shortcut.
Getting timesheet.
Yes, we are getting the timesheet. And also I need to get my timer set. We might as well time this out. If you guys are working on stuff, let me know what they are in the chat room, and we'll check in like 15 minutes and see how we're going. Let me get this password thing out of the way. Alright. So now I have this on my other computer. Actually, I didn't do any work on Saturday. I can show you what this looks like. So this is the timesheet format I've been using for years and years and years. Oh, so slow. This is slow. Courtney says, pivot tables. Yes, people keep telling me about pivot tables. I have never used a pivot table in my life. For those of you who don't know what a pivot table is, it's an Excel thing that allows you to do multi-dimensional sorting, I think. I forget why they're called pivot tables. I think in SQL terms, it's the same as a join. But they're called pivot tables because you select things and then it draws something out on the x-axis, something like that. It's a way of transforming, essentially doing a more complicated filter operation. It really is a join, I think. I'm not sure, though. Does that sound right? People who know things? Because I don't know. I'm trying to... Why is this so slow? Why? Okay. New color. Wow, this is so slow. What's the CPU use right now? 26%? That seems okay to me. It's April 1st. I expect a day of terrible jokes. Yeah, I'm going to hide inside all day because I'm not a huge fan of practical jokes. So what time is it now? It is 11:53. Let's say, I'm going to call it 11:45. I just rounded the nearest 15 minutes in my timesheet. And I have this fancy ass formula that will calculate the quarter hours, so then I can like just sum it up, see how long things took, 2.5 hours. Because I bill in 15-minute increments. So sometimes it's early, sometimes it's late, it all averages out. I don't think people care that much. Really. If I was a lawyer, I'd be billing in 6-minute increments. Probably twice. 2 clients at once. Because I'm that good. Alright, so I'm going to design the algorithm for connecting our graph nodes. Our graph nodes? I'm talking in... I'm very much aware that I'm doing this publicly, I guess. So how am I going to design this? So what I will do a lot of the times is... well, let me set the timer up first to get some timing going. Fortunately, I don't really have a good place to put the timer. I really need to make a browser source that will do that for me. Is there a way to do this? Something to work on. Oh, like Susan says, the channel URL is too long to see the mobile. I guess I could put... well, okay, we'll do that. No, Susan in the chat room was just saying, in the other chat room, saying that couldn't see the stream. DavidSay.com live is the live stream I'm doing for an hour of co-working. All right. Okay, that's taken care of. I am now looking at this. I was saying that before I got distracted. What I'll do is I will do some free writing. And what that means is, let me adjust this. I'm not quite sure where to start on this. So what I'm going to do is just start writing until something makes sense. Let's see. This was the week of March 25th, I think. Close enough. Week of... I'm not hearing a sound for some reason. I thought I just heard someone say something, but maybe I'm imagining it. Maybe that was me. The week of April 1st. Monday. I don't know if everyone can... if this screen is too tiny for people to see. I'll just zoom in every once in a while, and I'll talk as I type. So, anyway. Well, so what am I going to do? What I need to do to get unstuck. Let me start the timer also. See how long this takes. 15 minutes. This will beep in 15 minutes. Let us know what's going on. Now it is counting down. Alright, so I'll put this over here. It should start beeping. I could put the big timer on that monitor, but I don't have anything set up right now. Alright, so what is the task? I tend to program reflectively. We're talking about this in the chat room recently. Like, so the idea of that is like, I can't hold very many things in my head at the same time because I'm a bear of a very small brain. But if I can reread it over and over again, that helps my thinking process. I'm sure a lot of people are like this. You know, some really capable and productive programmers can hold like, you know, maybe 6 or 7 things in their head reliably at the same time. I can hold maybe 1.5 things. But so the way I augment this is just by writing down these thought loops. So I can just read it, react, and when I have a thought, I write it down so I don't forget it. This augments my poor working memory. So, and right now I'm even forgetting what I'm trying to do. So the question is, how do I draw lines from the edges of the boxes? Ow. That was painful. So now I'm going to take a sip of coffee. Now that I've written that down, I've gone past the hard part of remembering what it was I'm supposed to do. So now, let us see. Like, well, I'm going to just free write and clean this up later. Well, there are boxes, and the boxes have sides. So figuring out which side should be drawn from, so it's the closest to what it's drawing to, something like that. You know, so that's what I'm thinking. Let me I'm not sure why this is not just on this side. So this is oops. So this is what I've been writing. I don't know if that was, this is a little easier to see. Why is this box so small? I guess it's okay. Getting a lot of glare from the window behind me too. It's not really cool. Alright, so I need to read this aloud because I find my mind wandering. There are boxes. Now I'm going to condense this down. Boxes have sides. The question next is, what sides are drawn to where? Well, we're given a list of edges as source nodes, which are called W, and target nodes, which are called V. In this, I think this is a graph theory convention or something like that. W and V being source and target. I'm not sure though. So they look something like A, B, D, C, and we also don't care. Oops. We don't care about parenting. Parenting initially. I think we will eventually care about that, but for now I'm not going to care. So let's see, what have we figured out? I'm glad I wrote this down because otherwise my mind just went someplace like, I wonder if there's any good pizza places that are opening. So I'm, you know, I may have ADHD, I don't know. Inattentive type. Let's see. So I actually have to focus on this. One nice thing about live streaming is like, because I'm talking about what I'm doing, it actually tends to help me keep focused. So that's something you guys might try out if you feel like streaming something and you're not trying to build an audience, but you're just trying to share a little bit of process, try to get yourself through the day. Yeah. This ADHD life says, yeah, you might. I'm assuming that he's talking about having ADHD. And with a name like that, who am I to disbelieve? It sounds like a very authoritative name. And someone who has some experience with the matter, perhaps. Yeah, so ADHD life is from the Coworking chat room. So I can joke around with him. Let's see. Let's see. Oh, I'm seeing the chat appear in 2 places. That's kind of cool. I'm letting myself be distracted, but so I'm running this on the iPad over here, so I can actually monitor it while it's going on. So let's go back to the screen, and so I have this list of edges, source nodes. Sorry, we don't care about parenting. I'm going to take that out because I don't even want to be distracted by that. So this is what the list looks like. So then there's a question: how do you tell? How do you know? So I guess it would break down something like, how do you know A should draw to? Which side of A? I'm asking a specific question. Which side of A draws to which side of B? And I'm using this specific example because it's easier to think about that way. And I think it's something like, let's just write a table out. If A dot x is less than B dot x, x being the x coordinates, that means then A is to the left of B. Let me rewrite this too. A is drawing to B because directionality matters. D is drawing to C. So it's actually more like AX, or like a one, would be determine if A is to left, or A source A is, no, I should do it the other way. Drawing from source A to B is, I want to keep writing is to the left, but I actually want to write the other way. Let me just get this out to target B. Or to rephrase this, source A draws to target B to the right. That means if A dot x is less than B dot x, console log, it's on the right. So let's rewrite this. I know this seems maybe very haphazard. Ordinarily I'd be drawing this on a piece of paper, but try to do this on text. So if A is less than B, B is to right. So use A dot right to B dot left. If it's equal to it, that should never happen. So we can just do an else. Because there shouldn't be any overlapping on things. That should be denied by the layout engine. Else, or let's just write them all out explicitly. If A dot x is greater than B dot x, B is to the left, is to left. So use A left to B right. And now this is where it gets interesting. If AY is less than BY, then that means B is, like the coordinate is on the upper left is 0, 0. Upper left origin is 0, 0. Positive XY. B is to below, is, if A is less than B, then B is below. So use A left, right, bottom to B top. If AY is greater than BY, B is above, so use A top to B bottom. So I guess there's the tiebreakers. What happens in the case? What happens in the case where what happens. I've been trying to like reduce the amount of the length of my sentences. I'm trying to make things shorter. What happens when there's no clear, or how does it prioritize? How to prioritize between top or left, right, top, bottom, because there can only be one connection point. I would say it's probably something like we're looking at the magnitude difference. So let's look at this again. So if this is Z and it's connecting to X, so here we would want it to draw down there. Let me disconnect these nodes so I can see them a little bit clearly. So let's disconnect Z and X. Z and X we want to be separate. Let's go to DY. Let's get rid of that edge entirely. Let's see what this looks like. I should recompile. It's very slow. I'm streaming. Okay, so oh, here's X. That's a weird layout. Alright, so I should have just used Z, and let's say so Z, if Z is over here, we want this line to draw here. And it should still be drawing there until we want this to not, it actually has to be greater than the width. So it's not just X, it's CX, I think, the center of it. So if we're looking at the centers, in fact we could probably, we can probably use this node. Actually, let's connect Z and X. Let's get rid of these edges. Z, X. When that's compiling, I'll just go over here. It's very slow. Hope the audio is in sync. Alright, so here's Z and here's X. So here's the center point. So it's the center point. So here, ideally, we're drawing from the bottom to the top of that. And then it would still be drawing to the top and bottom. At this point, we're looking at the bounds, I think. So the magnitude difference between Z, X, I guess we're really looking at these edges. We need to look at the dimensions. So it's not just X, it's actually these bounding box relationships. So we need to choose, how would I express this? So the distance between the bounds, the left and the right, and the top and the bottom, the closer they are, or rather the farther they are. So in this case, the distance between the top and the bottom is very small. I think we can calculate this by looking at the width of the component, or the height of the component rather, and subtracting from X. No wait, is that right? So we look at the height of the components, because sometimes these could be different sizes too, like it was this. Where will you want to continue to draw it? You certainly don't want this to draw from here to there. In this case, which is the better looking one? Here to here, or here to here? I think the shortest distance is what we want to do. So let's express that as shortest distance between left, right, and top, bottom is prioritized. I'm not sure that rule is going to be complete by itself, but something to try. All right, so how do we calculate this? So we have, what can we easily get? We can easily get CX, CY, which is center, and upper left, props. Can we get the bounding box of it? And is that a complete bounding box? What would the bounding box be? I think we end up with things like, let's see. Actually, it just looks like this. It's C, calculate, a left, a right, a top, a bottom, and then also do the same thing, calculate B left, B right, B top, B bottom. And then we re-express our expressions as if, let's see, if, how does this work? If A right is less than, or actually it's absolute value of A right absolute value of A right minus B left. If that's positive, now let me rewrite this as an expression and then I'll convert the math, because I can't, again, hold this stuff in my head very easily. If A left is, that's the left side. I need to actually draw a picture to visualize this. I wish I could do this stuff in my head. Of course, I can't find a pen. The bane of my existence. Pens. All right. I've got this. Bad spatial reasoning. Let's get this down here. Let's go to Oxcam, why don't we? All right, so what I want to do. I'm going to draw these boxes. This is A. Let's draw B here. So we want to determine in this case, we want A bottom is less than B top. But if we had it more like A, let's say B, we wanted to go like this. Then we want, this is like A right is less than B left. If we had A on this side, we want to either draw either of these. That would be A top is greater than B bottom. Or it's B right or A right is greater than B left. And then in the case that A was above it, which we had up here, so I guess there are 4 cases. A is in the bottom. Do we have a pure bottom version? Or it's A top. That's the same, I just had that, could be bottom. I'm guessing there should be just 4 of these, but I'm missing one. A. We have the A on the top, A. Oh wait, no we don't. We have if A bottom less than B top. Well, I guess A can be in any one of these. A is what's circling around it, so it's either the bottom is going to be less than the top, or the top is going to be A bottom, A top. There should be a condition for each one, for each side, with the corresponding opposite. All right, I think that's how that would work. So let me go back here and get that back into position. So we're looking at the top, left, bottom, right of A. So we would express that as, if A left, there's going to be 4 of them. We were looking at A left. Let's use this in CS Editor. Top, right, bottom, left. Top, right, bottom, left. So if A top left, if A top, we're looking at the things we were looking for in the case where it's on the bottom. If T top is greater than B bottom, this is draw A. If A top to B bottom, if A right is less than B bottom, no, B left, draw A right to B left. If A bottom, and we want to draw from A out, if A bottom is less than B top, draw A to B top. If A left is greater than B right, draw A left to B right. Now I'm wondering if there's a hole in this. And we also had to weight these two. But I'm not going to worry about weighting it yet. So let's see. If A top is greater than B bottom, what I'm worried about is like there's going to be one of these conditions will fail, but I'm just going to write straight as this. No. Well, let's rewrite these as mathematical expressions. Go get the weight for free for that. That's arithmetic. So const use a. How do I do this? Use a is equal to, let's call this bottom, and use a. Use bottom would be bottom, and what am I thinking? It's a top minus b bottom. Oops. Then we have the equivalent expressions here. So in this case, we're drawing use right from perspective. And if it's using right, then we're going right, bottom. Someone messed this up. I got the order wrong. Let's try this. Use top. Use right. Use bottom. Use left. So that's top, right, bottom, left. What I'm trying to do is I'm calculating the difference here instead of using an if statement. And so, like, depending how far away it is, the value of this will be greater or less. Since I'm doing it like this, so let's, let me go back to the top. So we want to use the top of A. In fact, I'll put this, I'm going to put this in the variable name so you remember. If I want to use the top of A, that means I'm drawing up to the bottom, so that means A top is going to be greater than B bottom. If I'm going to want to use the right side of A, then B left is going to be, it's going to be B left. Minus A right. I think. A right, B left. Yeah, that's right. And then if I'm using the bottom, it's A top drawing down, so B top should be less, or be the greater value, minus A top, or wait, we're using the bottom of A, so B top, no, it's going to be B top minus A bottom. And to remember the direction of the coordinate systems, if it's left, if this, we're using the A left point, that means A is here, and then this is B, so A left is going to be greater minus B right. I think that's correct. A 15-year-old gay kid in ADHD is chuckling at the live screen. Why? I don't get it. No, yesterday was the Transgender Day of Visibility. I didn't know this, so I was invisible. Oh well. All new to all this stuff. So, okay, we have this. Oh, okay. Top and bottom stuff. Gotcha. I just found out what that was. I was like, yeah. Alright, so now I can rewrite these expressions. Now we'll combine these. Did my timer go? I forgot to start my timer again because I was deep into work. I'll just start again for the hell of it. I have about 15 minutes to go before I have to sign off. But I can come back later. Well, actually, this is probably all the stream I can do today because I have all these appointments afterwards. Well, tomorrow's another long day of appointments and stuff. Blarg. Let's see. Combining, we should get something like. Well, actually, I was going to combine the this conditional. I was going to replace this. Oops. I was going to replace this comment here with the actual math thing, but it doesn't make sense to define the constants like that. What I want to do is look at all of these and then pick the one that has the smallest magnitude. So actually what I want to do is this. I want to do a const weights is equal to I think I want to do this. Point top. And then we want to do weight. A top minus B bottom. No, I can't start thinking about it either. Point right. Weight will be a B left minus A right. Point, oops. Bottom. Weight B top minus A bottom. Point left, weight A left minus B right. Alright, so now we have this weights array. And so now that we have that, we should be able to write a reducing function. How does that work again? It's like weights, const choice is equal to weights. Is it filter or is it reduce? We want to return one value in the accumulator, so I think that's reduce. Reduce, and that receives a accumulator value and also the value. And we'll run this into this arrow function, and we want to return the value. That's the greatest. I'm not sure if this is this whole map reduce thing is kind of new to me. Maybe it's map that I want to use. I guess we'll have to look that up. Just to be sure. Script array map. Look this up for the millionth time. So, what does this do? It creates a new array with the results of calling a provided function on every element. Because that just creates a new array, that's not what I want. map is probably what I want, because I actually wanted to turn the I could use reduce or I could use filter. Which is the better way? What's from? Oh, it's like right copy routine? I didn't know we could do that. Oh wait. New shell card array instance and array like iterable. What? What does that even do? From 1, 2, 3. Why are they emphasizing shallow copied here? Oh, because it doesn't work with objects. Okay, nested stuff. Okay, so I guess we'll use map. You could also use it for each. This is map, right? What do they call their thing? This they have an object. Where are the arguments for this? Current value. Oh wait, I have this backwards. Current value. Oh, this is a map. I want reduce. Duh. I can't type. Why is this so hard? That's better. Reduce. Oh. Gets accumulator at current value. Returns accumulator plus current value. So I should be able to just munge the accumulator. You'll start index 0. Alright. So I think we're going to do this. It's warning me about my call. Let's check in. Alright, so choice. Current. So choice is going to be loaded with the value of this. So we're going to look at weight. If so choice is an object coming in, so we should just be able to modify it, right? So if current weight, we want to have the greatest distance or the shortest distance. Let's try it. If current weight is less than choice weight, choice equals current. Is it as easy as that? Pick the lowest weight. So I guess this is our algorithm. Alright, so all the rest of the stuff we don't need. Noink, gone. This is our initial algorithm for determining where to draw, or how to draw. I don't even know what to call it yet. So I'll have to figure that out eventually. But how does the interface look? This is going to be in some sort of, for like, to connect nodes. Let's call it connect WV or link WV. Connect point. And we have A, B. It receives two nodes, or these are not just nodes, these are visual nodes. So VA are Viz A and Viz B. And so then all of this stuff and I will stuff right into this guy looks something like const. A is equal to viz A. How do we call this get? So there's something, this is called something in collision detection. It's like the AABB something. I'm not sure this is exactly the bounding box. I already used that data structure elsewhere, and it's not the same as this. What should I call that? Get boundaries? Get axes? Is it axes or axes? Axis is plural, right? I don't remember. Well, get bounding X. That doesn't look right. Bounding edges. Get I don't want to call them edges because that means something in graph theory. Viz edges. Let's call them bounding edges. Viz equal to viz b. Get bounding edges. Calculate and choose the closest. What is the max int? There's something called math int or something like that. JavaScript number max int. Max safe integer, is that a real thing? There must be other ones. Max value? Min value? Generally we're dealing with integers, but and not guaranteed. What is the maximum representable value? That's a big value. It's a static property number. Okay, what other max What's the difference between this and max safe integer? Oh, the other one's floating point. Quadrillion. I think we'll use this max safe integer. Alright, 15 minutes is up. I've got like 5 minutes. So I need to wrap this up. But at least I got this algorithm kind of going. And it's part of a number. Ah! I lose. So I want to create an initial thing. So what I'm going to... This is to detect any errors. If none of these things evaluate. Oh, actually they all will, won't they? One of these is going to be less. I guess we have to make if current weight what I want to do is make sure that the current weight is positive. If it's less than 0, then we want to not do anything. If it's greater than 0 and current weight I guess we could write it like this in JavaScript. If current weight and current weight is less than choice weight, choice is equal to current. Otherwise, choice will remain this, and we'll have the error. So this should determine, well, only positive. Oh wait, no, negative values will also evaluate as truthy. Duh, okay. We do need to do that. Values. So after this, let's do some error checking. If choice dot point is equal to error, throw error. Could not determine side to draw from, or something like that. Alright, so this is kind of our algorithm. This is a starting point. I should be able to stuff this right into my visual class, I think. Or in the layout class. Wherever this is supposed to go. And then we return points, connection points. I think we already have code that does this. Return, oh, now we need to get the actual connection. Huh. So if it's the left or the right, I'll figure that out later because I had to actually get going to my conference call. So that's about an hour of virtual co-working. Hope you're getting some stuff done. I actually worked out this algorithm which was bothering me. You got to see my messy process. So if yours is better, you can feel good about it. If yours is just as bad, at least you're not alone. So thanks for watching. Hope you have a good week. And hopefully I'll see you later this week. Have a good one. Bye. Boink.